Hi, I'm Margaret.
And I'm Kelsey.
And welcome to this week's edition of Eater's Digest.
It's time to learn about our taste buds.
Wow, I'm just so excited!
So Kelsey, do you know how taste buds work?
No, let us find out. So what's the big deal about taste buds?
You experience the sensation called tasting when nutrients and chemical compounds activate specific sensory cells in the oral cavity.
Most taste buds are on the tongue. However, there are a few receptor cells that exist in the back of the throat, epiglottis, the nasal cavity, and even the upper part of the esophagus.
Young children also have taste buds in the middle of their tongue, and sometimes on their lips and their cheeks.
These cells are grouped together in clusters of 80 to 100 cells, and these clusters are what we commonly call taste buds.
You can't actually see your taste buds without a microscope, but they exist on small areas of the tongue called papillae, which are easily visible upon close inspection.
Each sensory cell is connected to nerve fibers that then send signals to our brains.
When taste cells are stimulated by binding of chemicals to the receptors, they depolarize, and this depolarization is transmitted to the taste nerve fibers, which send signals to the brain.
So where are our taste buds located?
Some may say that the taste bud map is kind of like a maze.
Rain makes corn, corn makes whiskey.
Humans primarily taste with the edges and dorsal surfaces of the tongue, soft palate, which is the roof of the mouth toward the back of the oral cavity, and pharynx, the area in the oral cavity that connects the nose and mouth to the esophagus.
You know that taste bud map that you learned in elementary school? Well, it's all wrong. Instead of all taste buds being identical and tasting different sensations depending on which area of the tongue they're on, actually there are different kinds of taste receptor cells and they kind of overlap all over the surface of the tongue.
So what are the specific taste buds?
Taste buds detect different chemical compounds,
Such as sweet, which usually indicates energy-rich nutrients.
umami, which indicates the presence of amino acids.
Some examples of these are meat broth or aged cheese.
Now that was especially interesting.
There's also salty, which allows for the regulation of electrolyte balance, such as sodium.
Sour, which typically represents the taste of acids.
And bitter, which allows sensing of diverse natural toxins.
So why did taste buds evolve in humans?
Well, human taste buds have evolved based on our environment and the nutrients that our ancestors sought. They would have used these to identify foods that were nutritiously rich and the food that they would need to survive.
In more specific terms, if you ingested a poisonous berry and you didn't have your taste buds, you wouldn't be able to know before you digested it fully, and it could possibly cause you to get sick or die. If you did have your taste buds, you would be able to tell that it didn't taste good and wouldn't be good for your body, so then you would either throw it up or just spit it out. Then you would save yourself the inconvenience of being sick or dead. Wait, humans have taste buds? Do animals? All vertebrates, with the exception of hagfish, have taste buds.
Cats don't respond to sweet tastes.
Birds, all with the exception of hummingbirds, lack the genes that code for sweet recepting taste buds. So the answer is yes.
So how does age affect your taste buds?
Taste buds regularly die and then regrow.
But around middle age, regrowth begins to decrease.
Youngins have more sensitivity to taste and prefer sugar as a natural pain reliever.
Pregnant women have heightened senses, excluding that of salty foods, which leads to cravings that meet the need for more sodium.
So how does diet affect your taste buds?
Well, spicy foods actually prevent pain by numbing your mouth, and it doesn't actually kill your buds. Bland foods are actually the real serial killer.
If we go without eating certain foods for extended periods of time, our reaction to these foods will be different. We become more sensitive to food, and therefore will not enjoy them as much.
Oh my gosh, this is super interesting.
Dieting becomes easier after a few weeks because you will be satisfied with less salt and fat than you were before.
High temperatures of food cause TRPM5, a taste receptor, to send a stronger signal to the brain when the food is hotter. This causes food to be more salty, sweet, bitter, etc. when we eat it.
So the food that we enjoy eating isn't determined by our taste bud sensitivity, but rather our exposure to the food.
I mean, what else were you expecting?
For example, a person doesn't choose to drink hoppy beer based on their taste buds. They choose to drink it based on their exposure to the drink or their determinedness to drink it.
Wow, isn't that excellent?
Real foods allow you to have many tastes, but these GMOs and modified fast foods allow you to have all the tastes you want all at once, which doesn't give you the same sensitivity that real food actually gives you. And it therefore ruins your life.
So eating unhealthy foods makes it more difficult to exchange real tastes. Eventually, We won't need these taste buds if all we do is eat bad food. It's possible that after many generations, humans won't have taste buds anymore.
So that's what's happening with our taste buds today.
Now we're all experts.